Welcome to this WaterProof webinar titled Industrial Urban Symbiosis, Funding and Practical Insights. My name is Alena Jans. I work at ICES and I will be your moderator for today's webinar. And before we begin, I have a small housekeeping note. This webinar is being recorded and will be made available afterwards on the YouTube channel of our project partner nova-Institut, who are hosting the WaterProof webinar series. So for those who wish to revisit and the insights that are shared today, or would like to have a look at also the previous webinars, you can find them on the WaterProof website. To give you a quick outlook on today's topics, our session is structured to take you from the conceptual roots of industrial urban symbiosis to the financial frameworks and finally into concrete technical and also regional applications. First, Mara Wagner from ICES will establish a foundation by defining industrial urban symbiosis. Second, James Woodcock from International Synergies will address the economic side, outlining various governance models and also the funding opportunities. Third, we shift from theory to practice. Hannes Utekal from Provider School and from Process for Sustainability at Industrial Park Höchst will join us to present how industrial symbiosis functions in real-world industrial settings. Finally, Erik Schuler from Avantium will introduce the Volta technology, showing us how electrochemical processes can turn CO2 into valuable chemicals within the industrial urban symbiosis context. Following these presentations, we will reserve the final 20 minutes for a moderated discussion, and throughout the webinar, we will also monitor your questions in the chat to include them in the discussion later on. So we encourage you to ask questions using the chat box located in the toolbar. This is us. My name is Alena Jans. I work at ICES in the Department of Environmental Psychology, together with my colleague Mara Michelle Wagner. Before we move to our first speaker, let's see who's in the room today. I invite you to join our Mentimeter poll. And in the beginning, we are interested in your professional background, so what kind of sectoral stakeholder you are. And you can either scan the QR code, or we also put the link in the chat. So we have a lot of research in academia, but also consulting, facilitating institutions, public organizations, municipalities, but also industrial stakeholders. Okay. Thank you for very much for all your responses. It's definitely great to see that we have a diverse mix of participants from research as well as from industry. Next, we are curious about your current level of familiarity with industrial urban symbiosis. here we have prepared some questions. And for instance, we would like to know, yeah. Oh, 1 second. Here we go. For instance, we would like to know, on a scale from strongly disagree to strongly agree, how you rate the two sentences. I am familiar with the concept or have heard of the concept industrial symbiosis or industrial urban symbiosis. And the second, I have practical experience or been involved in an industrial symbiosis projects in practice. So I think we have quite an informed audience. So many of you already have heard of the concept industrial symbiosis, and practical experience is a bit less. But that's also nice to see because we also get insights into practical applications today. Yeah, then the final Mentimeter question is, here we are a bit curious about which aspects you are particularly interested in, because this way we also can have this in mind in the discussion later on. So one is basically just that you're interested in the subject of industrial urban symbiosis, then the business and governance models, the ways of saving costs or having value from industrial urban symbiosis, maybe measurements of success. Okay, so I see business and governance models are very highly appreciated as topics today. And saving costs as well as funding opportunities. Okay, thank you. Yeah, then thank you everyone for all your responses. And to dive into the subject of our webinar, I invite my colleague Mara Wagner to give us an introduction into industrial urban symbiosis. Mara has a background in interdisciplinary sustainability studies with a focus on climate and science communication. And at ITSES, she's part of the Department of Environmental Psychology and currently working on circular and economy projects. So Mara.
Yeah. Thank you, Elena, for the introduction, and hello, everyone. I'm happy to introduce you a bit more to the WaterProof project, as part of which we are meeting today in this webinar. WaterProof, the long name, is urban waste and water treatment emission reduction by utilizing CO2 for the production of formaldehyde-derived chemicals. We are an EU-funded research project, having started in 2022, and we will finish this year in 2026. And the project focuses on an electrochemical process that converts CO2 emissions that are captured from consumer waste incineration and wastewater treatment into formic acid, as you can see on the right-hand side. This flowchart visualizes the interlapping waterproof processes with the electrochemical conversion process at its core. On the left-hand side, you see the CO2 sources stemming from hard-to-abide biogenic CO2 emissions, where CO2 then gets captured and converted into formic acid. And on the base of formic acid, different product applications are developed. The project's goal is to build a CO2 conversion pilot plant, a facility in the Netherlands at the site of one of our project partners. And with that, we aim to reach technology readiness level 6. And we're happy to to have Erik Schuler on board. He's an expert at Avantium, and in the last presentation, he will give a bit more detail on the technology. With our research, we focused on different test applications. The first two are cleaning detergents and the tanning of fish leather apparel, both using formic acid, and another product that is synthesized on the base of this renewable formic acid are ADs, acidic deep eutectic solvents. This is an emerging and promising method used for the recovery of critical raw metals from incineration ash, from solid waste and wastewater sludge. I linked you here a fact sheet. You can access that afterwards. It's a recent publication from our project with more detail on that. Here you see a quick overview about our broad consortium. We are also happy to have our project partner and renewable carbon specialist Nova on board. They are the technical host of this webinar. And next to the external communication of our project, they are also doing life cycle assessment analysis of the waterproof technology. But also we want to introduce ourselves quickly. We, as it says, we are an independent non-profit research institute working application-oriented and system-focused on energy and sustainability topics. We are with our main office located in Saarbrücken, that's in the western Germany, close to the French border, but we have a second bureau in Berlin as well. We are affiliated institute with the University of Applied Science, HTW Saar, and we are an external research institute of the Saarland University. And at the moment, there are around 18 employees working here with an interdisciplinary focus. We are organized in 5 different departments, and my colleague Alena and I, we're both working at the environmental psychology, where we do research on acceptance of renewable energy technologies and participation processes, as well as accompany circular transformation processes with a systemic multi-level perspective. And that we also bring into our task within WaterProof with a mix of methods. On the right, you see our multi-level approach. And going now from big to small, right now we're currently focusing on the broader industrial and societal level to examine factors for engaging with IUS. And this is also the reason we're meeting here today in this webinar. But we also did qualitative social research through interviews with various stakeholders along the waterproof value chain to explore their perspective on this new technology. And we are currently in the data analysis of an online survey we did with consumers in Germany, the Netherlands, and Colombia regarding their perspective on the new CCU-derived products. Now we're getting even more to the topic, industrial symbiosis. Where does it come from? Like many other groundbreaking ideas, the concept of symbiosis draws its inspiration from nature. Mycorrhizal networks, as you see here, demonstrate how, for example, fungi and plants exchange mutual nutrients, therefore sustaining each other, but also strengthening entire ecosystems, for example, also against external disruption. These natural resilience networks are also studied by academia, especially from the interdisciplinary field of industrial ecology. And for especially since the 2010s, there is a stronger focus on industrial symbiosis, researching how industrial actors and processes can be interlinked and work mutually benefiting in ways similar to nature. But now we heard the term quite often, so let's clear that up so that we speak about the same thing. What is industrial symbiosis? It is the use of one company's underutilized resources by another, and that can be waste, byproducts, residues, but also energy, water, or even infrastructure, capacities, or expertise, with the goal to keep the resources in a productive loop, integrating sustainability in the industry sector and supporting the transformation towards a circular economy. We are at the moment also working with an extension of that, so-called industrial urban symbiosis, where a symbiotic system integrates as well urban material streams such as municipal solid waste or wastewater from households as feedstock, and therefore creating a collaboration between businesses and urban waste management companies. There are many reasons to pursue symbiotic industrial collaborations. We summarized a few highlights here. Industrial symbiosis can foster resilience and resource independency. And I think right now we're experiencing quite strong, volatile global markets that are easily disrupted. At the same time, industrial symbiosis forwards sustainability goals and contributes to a circular transformation of the industry sector. And embedded in all of this is for sure the aspect of creating economic values, as this is vital for strategic decision of business. But here, industrial symbiosis enables the reduction of waste costs and, for example, also the generation of new income streams through the valorization of side products. Maybe some of you that are familiar with industrial symbiosis know this example already, and I saw in the beginning that also someone from Kalundborg Symbiosis is here part of our audience, which is really nice to see. Kalundborg Symbiosis is located in Denmark and is a global blueprint of industrial symbiosis, existent since the 1970s. Their symbiotic network consists of 17 partners, which are public and private, and are connected via 20 different resource streams, as you can see on the right-hand side. We also want to advertise a bit because we recently published a fact sheet on more insights on industrial urban symbiosis, where we summed up as well some drivers and barriers, and we want to quickly highlight some of these aspects here as well. Because various drivers, for example, the understanding of benefits, the existence of forerunners and blueprints, as well as the existence of facilitation entities. I think James will explore a bit more on that. And the existence of diverse industries, they foster industrial symbiosis. But on the other hand, there exists also various barriers. For example, on the financial side, there could be high processing or logistic costs. Management-related barriers can refer to a lack of management support or a lack of trust between partners. There can be informational barriers, for example, also the lack of awareness of the concept itself. Various technological barriers, for example, that the infrastructure is not ready for symbiosis. And last but not least, policy and regulation play a huge part. And sometimes complex and even contradictory waste regulations rather oppose industrial symbiosis than to enable that. Our approach with this webinar right now is to give you information and room for an exchange, also information on funding opportunities, and also some insights into blueprints and technological innovations that can unlock industrial symbiosis potentials. But as you might have known, we're not the only one focusing on industrial symbiosis. There are many current interesting projects running. On the right-hand side, you see collaboration of different EU projects working currently on this topic. Behind every one of these logos, there's the link which will lead you to the project homepage of this project. Maybe that's interesting to look at afterwards. And then there's also a publication by the DG Research and Innovation that sums up and reviews past EU projects focusing on industrial symbiosis. It is an interesting read. We can recommend that. And also during our research, we stumbled upon the industrial symbiosis screening tool, also from Kalundborg. There is an extensive Excel sheet with also an online tutorial accessible via their website. We linked that here below. And also inspired from Kalundborg, but also from a recent dissertation project from Hafeld and colleagues, we came across the symbiosis readiness level, which might function as a good visualization of the process of initiating an industrial symbiosis initiative. And with that, I finish my theoretical input for now, and I look forward for Alena introducing James and his presentation. Thank you very much.
Yes, thank you, Mara, for that comprehensive overview. Moving from the conceptual introduction from Mara Wagner to the business cases and funding opportunities, I moved to the presentation from James Woodcock. He is a senior project manager at International Synergies Limited and has extensive environmental and industrial knowledge gained from over 30 years in roles that crossed industry boundaries, both in the UK and also internationally. Within 20 years international working experience, James currently supports the delivery of industrial symbiosis programs in several countries and has previously delivered projects in over 25 countries across 6 continents. So James, we look forward to your insights.
Thanks a lot, Elena. Thanks, everyone. It's a real pleasure to talk to you. I'll start with a very brief introduction of who we are at International Synergies. So, as mentioned, we've been operative since 2005 in over 50 countries, helping those countries to deliver practical industrial symbiosis through various means. And those various means are industrial symbiosis facilitation, where we're teaching them how to be facilitators to help industry identify and realise IS opportunities. We've developed a resource matching platform, Synergy, that's been used in over 25 countries, and also helping them to understand net zero strategies that can operate within industries. And then at a strategic level, we've worked on things like place-based decarbonisation strategies, which is where you're looking at a region and saying, okay, well, what have we got there? And what can we do with it? And what's missing? And how do we attract that and bring that in? All from the aspect of industrial symbiosis. And then capacity building, where we train people. We actually get people together and train them through from a standing start where they know nothing up to the point that they can actually deliver practical industrial symbiosis, either within a company itself, within an eco park or a region, or delivering a facilitated program. And then we do lots of collaborative activities and research, such as the H4C ECOP, the RISES project, and other projects in the past like Circling. So we do a lot around things. Now, Mara's already said about what is industrial symbiosis. You've seen this definition, so I'm not going to go into that. But I do want to attack a few misconceptions that there are and some of the language that gets used when people talk about industrial symbiosis. So quite often people talk about just some of the examples here, sharing or exchanging resources. The reality is when you actually talk with companies, they actually buy or sell those resources by and large. So it's much more of a transactional interaction that you have between companies rather than sharing or exchanging the exhaust. I'm not giving you a resource and you're giving me something back. I'm actually selling it you and you're paying me money. And then the reason we use terms like underutilised resources is that it's a much wider definition and much wider remit than if we were to just focus on things like byproducts. And then there's other aspects of it as well, where people quite often in their definitions, they might talk about things like geographic proximity, when the reality really is that the proximity depends on the value of the resource. So things like metals can move quite a large distance, hundreds of miles. So when people talk about and give a definition of industrial symbiosis that talks about geographic proximity, there is quite a lot of that. But when studies look into it, there's an awful lot of resources that do travel quite a good amount of distance. And there's some other examples there, but for time, I won't go into them. Now we're going to get to the meat of what I'm going to talk about, which is things like governance models and financial instruments. So if we think about governance models and we go back to this CWA, this working agreement that there was from 2018, which is currently being progressed into a proper standard, moving towards that way. It talks about 4 different governance models, and I'm going to take you through those different governance models, but also explain how this definition of them is a bit too rigid for what is actually like out there. So if we think about this, self-organised was the first one. And that is really a bottom-up approach where companies come together and it's very ad hoc and serendipitous in that they find out what each other are doing. And from that, they identify opportunities. But there's no real formal governance. And it can be quite difficult to replicate that type of thing because it is so ad hoc. And of course, that is how Kallenborg actually began his companies on an ad hoc basis, creating transactions between each other where resources moved from one to another company. Now, Kallenborg has moved into, it's moved beyond this as it has grown and become more known. But ultimately, it started off as this self-organized structure. The next is a facilitated structure, which is where you have an organization that works with companies and other stakeholders to log who is there, what are the industries, what are the resources, and look for ways that those companies and those organizations can work together, bringing in their connections and looking for opportunities, and then working with those members, those companies, to actually identify any barriers and trying to overcome those barriers. An example of that would be the UK's National Industrial Symbiosis Programme that's been replicated in lots of different countries, and I've given you some examples there of where they've been replicated. So WISP is in South Africa, ReWin was in Netherlands, and INI-RMS is in Northern Ireland, for example. Then there's this one, ICT enabled, which is listed as a governance model. And really, when you look into it, it's not necessarily actually a governance model. It's not, it's more of a supporting mechanism in that effectively you have a resource matching platform where people can log who they are, log their resources, and use it to try and find different opportunities for those resources. There's lots of different examples out there. Some of them are successful. The vast majority tend to die after a couple of years after the project ends because of funding or other issues. So it can be quite difficult to actually identify ICTs that are stable and will be around for a long period of time. Examples of that are things like Synergy, Recircular, Marketplace, and quite often countries will test a model out and then decide that they want to build their own, purely because they can then say it's ours and we've built it ourselves. So yeah, the big question with ICT enabled is it actually a delivery model or is it a support mechanism? And then the final governance model is strategic or planned. So this is as opposed to self-governing, which was a bottom-up, this is the top-down approach. And this is where a region will look and say, how do we develop our region? What do we need to do? And what's there? What can we do? And what's missing? And how do we attract that in? And there's lots of examples of that. So South Korean EIPs is one example of that. And again, is this a delivery model or is this an enabling activity? Because what tends to happen is that they'll develop a structure, they'll develop a mechanism, but then the actual implementation will not necessarily be through this. It will be through one of the other models that we've already discussed. And that is a really important thing to understand, is that these models do not have rigid lines around them. The reality is that the lines between these models is quite fuzzy, and you will actually more often than not get a blending of these different delivery models in how industrial symbiosis is enacted. So if we think about some of the barriers we've got along the top, this is quite involved and we could camp here for quite some time, which I won't do. But what I will do is direct you to H4C ECOP deliverable, which is the mapping of non-technical barriers and enablers for these models. And this is pulled from that. And we looked at lots of different potential barriers that there are with regards to different types of industrial symbiosis and how each of these models addresses those barriers at scale and in a replicable fashion. And ultimately, what came out is that a facilitated model is probably the best way that you can attack these barriers at scale in a replicable manner, purely because it is structured. It is structured and it is targeted, whereas much of the other happens by either ad hoc or through specific target rather than looking at things throughout. So I'd recommend looking at that particular deliverable from the H4C European Communities of Practice, ECOP, which addresses this in much greater depth than what we can do here in 20 minutes. The next thing I want to talk about are things like KPIs, which is another thing we looked at. And obviously, key performance indicators can be important with regards to, well, what am I measuring and why am I measuring it? Because ultimately, if you are delivering industrial symbiosis, you need to know if it's any good and are you actually achieving benefit. So I've been on lots of projects. I've had some good KPIs and I've had some terrible KPIs. But ultimately, if we want good KPIs, they need to be well defined, quantifiable, relevant, and aligned with strategic goals. And quite often somebody will give a KPI that just says something like save carbon. And you then look at it and you go, well, how are you measuring that carbon? What type of carbon is in scope and outside of scope? And before you know it, you're actually having two conversations. What one person's talking about on their KPI is not necessarily what the people who are doing the project on the ground are thinking about. So the communities of practice, the hubs for circularity, they had two projects, one looking at assessing a suitability of a region or industrial area to implement IUS, and one looking at how can you create measurement KPIs and creating a methodology for creating smart KPIs and what type of KPIs do you need for industrial symbiosis. So if we look at towards what the development of the smart KPI side of it was creating a methodology, came up with this core set of environmental, economic, and socials, and then actually gave a good definition for each to remove that ambiguity that I spoke about. And it looked at lots of different projects and what KPIs they were actually doing. We held what we call a sense-making event, and what that is that we brought lots of people together to actually find out how were they coming up with the KPIs, what type of KPIs were they using, and how did they define them. And we also presented to regions and cities and said, look, here is a set of KPIs, and this is how we develop KPIs. Do these seem sensible for you with regard to developing IUS? Lots of projects, as I mentioned, lots of projects that we looked at, and here that's the list of the projects. And ultimately, these are of what we found. So we looked at this suite. We didn't want lots. So quite often when people develop KPIs, you can see numbers in the tens and even approaching 100. We wanted to keep it down. So we looked at how many of each KPI came across different projects, and you can see the results here. So we kind of blended it down to about 10 KPIs if we could. And ultimately we came up with this methodology for developing KPIs of how are you going to measure. So effectively what we've got is these are the common KPIs, and we say if you're going to do an IS project, chances are you're going to end up with these KPIs as a minimum. So what we said is use these as your starting point. These are the types of things that you'll have. And any new ones that you develop, you'll want to go through this type of process, purely because then you'll end up with a smart KPI that everybody knows what it means. It's unambiguous, and it's giving you an actual purpose for measuring what you're measuring, rather than just having a big list of things to measure. Then for each KPI that we said, these are the ones that we're going to have, and you'll notice in the previous list, we had landfill diversion, where that has changed here to resources raised through the waste hierarchy. And that's really because your KPIs, if you are delivering IS, your KPIs will influence what is in scope and what is out of scope with regards to what you can deal with. And if your KPI is, say, I'm going to measure landfill diversion, well, that kind of means that that's your starting point. Is your resource or your waste going to landfill? And if it's not, then it might be out of scope for your project. Whereas if you have a KPI of resources raised through the waste hierarchy, it doesn't matter where its current fate is. What your job is to try and get it to the next rung of the waste hierarchy. So what we did is we came up with this common set of KPIs and gave each one a different definition of what it actually is. And all of that, again, is in one of the deliverables from ECOP. Which brings us to our final section, which is now funding opportunities. And again, this is based on a ECOP deliverable, which is your way through funding IUS in the EU. So that really was designed to look at how do you navigate the financial landscape? What actually is there out there? And if I'm a different type of an organization, what are the best options for the type of organization that I am, trying to deliver a specific type of industrial symbiosis? And it looked at all the different types of funding, the barriers, the benefits. Can you blend financing? Can you bring some funding from one stream and another stream? What are the different EU funding schemes, and also commercial financial instruments and banks? So there's a lot in there. And this really just tells you what we did. So with regards to laying out overviews of different mechanisms, introducing them, highlight concrete sources. So if I'm looking at this, where can I go to get this funding? What are the types of projects it has funded? How does it work? What's its level of intervention? And what are the types of results that they're expecting me to achieve? And for each support scheme, this is the basic way it covers it. So it looks at what type of organisation is the funding scheme suitable for? What project stages does it cover? And these are all the different types of project stages that it looks at. And for each scheme, it introduces it, gives you the suitability and its criteria. And then it looks at things also, looking at other things like national and regional investments. So, if we're looking at a national or a regional project, what are the different types of delivery that can happen within them, and how are each of these funded? So it could be a grant, it could be a contract. You can have national, regional, or even a mix. What are your metrics, and how do you align them, and how do you define them? Do you put them to policy objectives? Do you put them to political objectives? Do you put them to industry objectives? All of these different things will have a influence on the delivery of and the structure of an IS activity in a region. Is it free? Do you end up charging? And also, you have a need to identify continuity funding, because if you don't, what generally happens is you have a 2 to 3 year project, and at the end of it, everything dies, and all the companies who have been interacting with it go, well, what do we do now? So it's always useful to have continuity funding. And then also you can look at, well, what are the different objectives that we might have? Are we just looking for resource efficiency? Are we looking to beat competitiveness? And so on. And depending on what your objectives are, that will influence the type of resources, the type of organizations, companies, what you actually do. How much is waste management? How much is about, do you need to get research involved? Do you need to get parties who can transform materials so that somebody else can use it? Or are you supposed to be going straight B2B? So it's a resource that can come straight out of one company and into another company. So all of these influence the type and the delivery of IUS activities. And then where do you actually find funding itself? You can go to government departments, whether that's national or regional. You can blend, so you can do cross-funding, where you can look at different pots of money and bringing them together. Or you might just have a single or even a multiple delivery bodies, different delivery bodies that actually do the actual delivery on the ground. So it might be a single body, it might be a conglomeration. You might, and then you go up that tree of, we've got people together, who's going to pay for it? How do we get that money? How much money do we need? And whose do we get? Do we go to national? Do we go to grants? Do we go to EU? That sort of level. So there's all of these types of different aspects that you need to think about when you are creating an industrial symbiosis activity. That was very whirlwind. I know it was. There was a lot to get through there in 20 minutes. But what I would suggest, what I would advise is go to each of those 3 deliverables from the Hubs for Circularity ECOP project, and each of those will expand on all of those aspects that I've spoken about. So thanks a lot for listening, and any questions we'll deal with at the end.
Yeah, thank you very much, James Woodcock. It's great to see how specific barriers in industrial symbiosis can be overcome by selecting specific governance models and to know more about the measurement of KPIs, but also how and where to look for funding. To see how industrial urban symbiosis can also look like in practice, our next speaker, Professor Hannes Utikal, joins us. He's head of the Center of Industry and Sustainability at Provades School, and in cooperation with several other companies at the Industry Park Höchst and other innovation partners, the Center for Industry and Sustainability is leading a cluster called Process for Sustainability. So Hannes Utikal, the screen's yours.
So Lena, I'm happy to share a few of our examples and experiences got with regard to the industrial urban symbiosis in the area of Frankfurt Rhein-Main, and especially on the Industrial Park Frankfurt Höchst. Oops, I try to move to the next one second. Here we go. We are based at the large industrial park, and industrial parks in Germany currently have a dual challenge. On the one hand, they have to fight for competitiveness. They have to have competitive energy supply prices, and they have to make sure that everything runs smoothly today. And at the same time, they have to prepare for a climate neutral future, in the sense that we will have renewable energies in the future. We need to find new business potentials. We need to make sure that we use resources in the area much more wisely than in the past. So in this context, this industrial park, founded in 1863, so more than 150 years ago, is a huge park with around 90 companies and 120 production plants. We do have all parts of the chemical industry somehow there. We do have as well pharmaceutical production, specialty chemicals there, something like the chemical industry in a nutshell you will find here. 20,000 employees, and you see that we've got around 2 terawatt hours of heat and around 3.5 terawatt hours of heat and 2 terawatt hours with regard to electricity. So it's like a city with the Verbundstruktur that we've got as all the old industrial areas based in the chemical industry in the past. And this industrial park, we do have Provades University of Applied Sciences, and there's the Center for Industry and Sustainability. And while you do know that in all those industrial areas, you've got water, material, energy, and production flows, we focus especially on the knowledge flows around there, checking how to optimize activities, identifying potential linkages within the park and in the park and the area. In this context, we are focusing on developing innovative ecosystems as well, have complementary partners for our activities. In the past, it was a lot EIT Climate Kick. Currently, it's much more locally, so that we have more on the ground business impact than in the past. When we're talking about industrial urban symbiosis, we focus on the optimization of energy waste and byproduct use. We are thinking about how to share utilities and infrastructure. We think about how to use services on the ground in the park, and how can we have a joint learning process. We've written all this as well in a paper from 2024, I think, where we described industrial symbiosis as an enabler and a barrier for defossilization. If we have a look at what's going on today with regard to the optimization of energy waste and byproduct use, I can highlight that we do have combined heat and power generation. We're using waste heat, and we have the usage of hydrogen within the park for fueling the buses. We do have the joint provision and joint purchase of energy and resources, having CO2 from biogas, for instance, and we are burning as well waste for the generation of heat. Our activities in the cluster process for sustainability would be an example of a transfer of experience in joint learning. So that's what we're doing within the park, and I will come up with a few charts highlighting that. In addition, urban industrial symbiosis, we do have activities that we are checking how to have district heating from the park. How can we use hydrogen as well for fueling the fuel cell trains we've got in the area? How can we have something like phosphorus recycling from municipal waste? And we do link, of course, as well with different expert panels in the region in order to make sure that we are identifying fields for improved collaboration and resource looping. So the industrial park has more than 100 years experience with the generation of hydrogen on the one hand, as this is a byproduct of one production process we do have there on site. And based of this hydrogen, we have identified a variety of options on how to use this hydrogen. For instance, we do have in the area, I think, more than 20 regional trains that are fueled now with fuel cells, and they are refueled with hydrogen from the industrial park that we've got there as a byproduct. We are checking how we can combine the different resources we've got in the industrial park in order to come up with new green chemistry options. One is, for instance, Ineratec creating eSAF on the base of CO2 and hydrogen, for instance. We've got other projects where we are checking how we can have green chemistry based on those renewable input factors, for instance. And we are focusing on those activities that are not in the lab scale, but those activities which need an upscale in industrial context. So we are not focusing on the real startups, but once the technology works in the lab, we are very happy to have them on site for the upscaling of those activities. So the basis of everything is that we do have an integrated heat and electricity network where we are checking how to optimize from a economic and ecological perspective the energy supply. That's the starting point. In addition, we do have those biogas plants for having as an output biogenic CO2 as well that can be used as an input factor for chemical production processes. And there we just had last year one project that was just mentioned before from Industrial Symbiosis to Hubs for Circularity. There was one project where we are checking how to do the carbon capturing activities in real life. So this is a not that easy activity. So we are experimenting what would be the different resource flows we can use and what would be the cost for having carbon capture in order to have more carbon, more CO2 to be used in the future for chemical production. One example I mentioned before is this Ineratec company, very successful scale-up activity that is producing for the Frankfurt Airport, for instance, as well, e-fuel activities, and they are just improving their size and getting bigger and bigger there on site. The core idea is that we believe that those industrial parks, as I mentioned before, founded partly in 1863, they do provide a variety of relevant infrastructure or energy supply for disposal, for instance. We do have sustainable raw materials there on site. We do have as well the possibility to mix and combine those different resources again for creating new products. We are thinking that we are an innovation campus for this upscaling of activities. And finally, we do believe that we do have as well relevant networks that can help for those industrial scale-up activities, as we do have not only the academic but as well the policy networks that can be helpful for scaling up those clean tech technologies. So we believe that those industrial parks can have, to a certain degree, an industrial revival in order to come up and reindustrializing Europe as well. And one part of those activities is as well that we are checking how we can defossilize those activities with our cluster process for sustainability. And what is very important to know is that our own defossilization path is linked to the electricity and hydrogen grid we do have in the area, and we do need to have in Germany. So we have to focus on the transformation process we do have on societal level as well, in order to make sure that the hydrogen grid will be ready as soon as possible. The electricity grid has to be ready as soon as possible. Currently, we believe that we will have those networks by 2030, but this will mean that we cannot really defossilize our activities much earlier. So when we are thinking about industrial urban symbiosis and defossilization, we always have to think as well about the surroundings to make sure that we can accelerate our own defossilization path. This brings us to the need that we have to focus not only on technological and economic aspects, but as well on socio-technical systems to understand what is the dynamic in order to have acceptance for those new technologies. And as you see every day, we do have a volatile thinking about the support for defossilization of Europe, how to balance economic and ecological aspects in the light of those different wars we are currently facing. So we have to be engaging in all those debates regionally as well in order to secure the support for our own defossilization path. This brings me to one struggle of industrial urban symbiosis, saying that on the one hand, you would say, of course, we all know that we have to work together in order to create this industrial urban symbiosis, but very often we do have a fragmented transition policy mix. We do have a multi-level governance, hindering to a certain degree a fast industrial urban symbiosis. We do have a polycentric governance with different decision-making entities. So very often it's very hard to come and to realize the business impact you would like to have due to this scattered policy-making process we do have. If I use the different examples James mentioned before, we do have partly self-organized industrial symbiosis models. We have from European Union funding initiatives where we are analyzing the raw materials we do have in the region. Bioball would be one of those examples. And we try to identify as well the CO2 in the region of Frankfurt, but it's not that obvious to get the data you would need in order to identify how this industrial area could be a hub for carbon management in the area. So with regard to biomass and CO2, we do identify a lack of reliable data in the region. And so it's not easy to come up with a business case on how to have a quick defossilization based on those important raw materials. Within the park, we do have a much more strategic or planned industrial urban symbiosis, identifying and knowing about what the resources are and focusing on the most important resource flows as well with the region and checking whether there could be as well district heating initiatives with a reliable business case. So we do have quite a variety, James, of your models you mentioned before. The ICT-enabled mechanism you mentioned before is for us a difficult part, as if you only have the data in a database, it's not really useful. So we always start with the assumption of the potential business case, and then we start to look in and dig for the data in order to make sense out of it. We did as well something in the past where we are highlighting resources we do have in the region, but if there's no one really interested in it, the danger is that you create like a data cemetery, you would say in German. So My core message is thinking about industrial-urban symbiosis means that we do have to focus on the business case, on the technological and so the societal readiness level of all those activities. And for us, it's most important to find a reliable business case, because otherwise it's very hard to bring people together who might think about potential collaboration if they don't see the direct, immediate economic benefits within that context. Thank you. That was my little impulse.
Yeah, thank you very much, Hannes Utikal, for that impressive look at the Höchst Industrial Park. Yeah, and seeing all the different synergies that already exist and that you're looking into, as well as seeing the highlight of highlighting the importance of networks and also the relevance of having a business case. Our final presentation today bridges the gap between industrial urban symbiosis and carbon capture and utilization. Dr. Erik Schuler is a process engineer with 10 years of experience in CO2 conversion. He has converted CO2 using plasma chemistry, catalytic synthesis, and electrochemical routes. He earned his master's and PhD at the University of Amsterdam, focusing on CO2-based polymer production. And at Avantium, he developed processes for CO2-derived polymers, specializing in design and integration. So, Erik Schuler, I give the word to you.
Thank you. Do I have to share my own slides, or do you share them?
If you want, you can share them yourself. Otherwise, I think we can.
If you can, that would work better, I think.
Yes, give me 1 second and I will share the slides and then, yeah. Okay. I have too much open here. One moment. Erik, the floor is yours.
Thank you. Yeah, perfect. Welcome everyone. I am gonna give you an idea of what we do at Avantium. So for a bit of context, if you can go to the next slide. Avantium is a company that's listed on the Amsterdam stock market and Brussels stock market. We're headquartered in Amsterdam. We're like 300 people, and we focus a lot on knowledge development. We have like over 150 patent families, we're in the business of making chemistry greener, basically. There's sort of 3 main areas Avantium is busy in. There is the bio-based plastic. That's the product is called Relief. We make PEF as an alternative for PET. The more legacy business is R&D solutions. That's how Avantium started, as a company that develops and uses for customers equipment to test catalysts to improve efficiency of catalytic conversions. And then there's the third part, mainly, that is the Volta business unit. That's where I'm part of. And there we go to the next generation. So we want to use CO2 to make chemicals and polyesters. And we use electrochemistry as the pathway to do so. The overall mission of Avantium is basically to revolutionize materials for a sustainable world. That's a bit the mission statement. We want to help moving away from fossil-based chemistries to basically a circular carbon economy, and we do so as a chemistry company using chemistry. One thing that's pretty close to our heart is advocating a bit against decarbonization. That's a bit of a big word that's always around, but really, we need carbon. Carbon molecules are in all our products, so we should be aware of that. So if you hear decarbonization, better think of defossilization. So carbon is necessary. We humans also consist mainly of carbon, but we should really not get it out of the ground anymore, but reuse the carbon we have above the ground. And it's not just in us humans, it's also in energy sources, as we know, and a lot of materials we use, like polymers, plastics, and others are made from carbon. So we need to replace the fossil carbon, which is very easily available to convert, with other sources. And one of them is CO2. And what we do at Volta basically is that's the next slide. Yeah, exactly. Is we use CO2 and renewable electricity in our electrochemistry platforms, and we make different chemical intermediates. Um, we do not have just one singular product, but we basically develop solutions for sustainable protein feedstocks. You can make cleaners out of it. The WaterProof project is one of the examples there. We ultimately want to make plastics from CO2 to replace fossil-based plastics, but some of the intermediates you could also use in personal care. So we have many different applications, and that's also important to grow a business case like that. You can't just go for the high volume in the first place. So we have a bit of a stepwise approach with a broad range of existing end markets. And then you have also high potential growth applications. So it's a bit of a mix of that. So you have to have we believe you have to have a strategy that just doesn't go just for once, but where you, in this evolving field, can look at different things there. So I want to give two more specific cases what we do, use cases. One is in the WaterProof project. So a lot of these technologies we're developing in at the moment within these larger EU projects where we really, so that's why in the symbiosis is interesting for us. You always work with different partners together. We are very used to that already. For example, in the WaterProof project, as we've seen, we use the CO2 from wastewater treatment plants or waste incineration plants. What we do here is we put the CO2 and hydroxide into a so-called bicarbonation unit. We make an electrolyte that's bicarbonate, basically baking soda solution, if you will. And then you can use electrochemistry where the important feedstock for CO2 conversion is energy. And the nice thing with electrochemistry is you can very easily use renewable electricity for that. So you, of course, should not burn fossil fuels to convert CO2. You might not have won anything at the end. The people from NOMA know quite a bit about that from their LCA studies. So we use the CO2 and convert that into formate. That is basically a salt which we receive in a solution, and that salt we can then again turn into a acid. So another electrochemical process where we make formic acid that can be used then. If we go to the next slide, formic acid can be used as cleaning goods for the household use. So you can make, for example, toilet cleaner out of it, replace current cleaning solutions using making that from CO2. Formic acid is also used in the tanning industry. So you can make tanning products. And here, for example, quite interesting, our partner is Nordic Fish Leather in Iceland. At the moment, they ship the formic acid they use to Iceland, a rather remote location. So here you also can see, for example, a more localized symbiosis. You use CO2 that is produced there, for example, and then you make the product you need on site without transporting formic acid halfway around the world. So there could be advantages there too. And then we work on deep eutectic solvents. That's what formic acid can be used to remove metals such as copper and remove heavy metals such as lead from different waste streams. So can be directly used, for example, again, in these applications where you actually produce it, so on site of these waste treatment plants. So there you can see where these units will go. We have 2 demonstration sites. One is at Waternet. Waternet is basically the wastewater and water board of the Amsterdam region, if you will. We will have our units sitting at the facility in Amsterdam and use the biogas produced in the fermenters from Waternet. And the second location it will go is HVC. That's again a bio-waste incinerator in Alkmaar, but further north of Amsterdam, also in North Holland. So B-wood is incinerated there. They make, of course, CO2, and we can then convert that CO2 to the formic acid. But as I said before, we can not only make formic acid. That's a pretty simple thing to make, but also not so high value. So second case study I want to show is the Hiccups project, where we again use biogenic CO2 and electrochemically convert it via oxalic acid to glycolic acid and then go all the way to making a polymer. So if you want to do that, there is a bit of a more complex process needed, of course. There's more steps involved. If you go to the next slide, you can see here in the overview, we have to first capture the CO2, then we have to separate it. And whilst in the first case, in the WaterProof project, we basically reduced the CO2 and then made an acid. In this case, we reduce it to formate. And then the second step is the so-called formate coupling. If you want to make longer chain molecules, you have to have a carbon-carbon bond established. That's pretty difficult to do with electrochemistry. So what we do here is we make the same formate, but then we couple it with a carbon-carbon coupling and make oxalate, which we can then again acidify, again electrochemically. We can also recover here the hydroxide, make again the bicarbonate, and go then further from the oxalic acid to make a glycolic acid using a hydrogenation process. And then there is some intermediate steps where you have to make, if you want to make polymers, you have to have really, really pure starting compounds. So we work with VTT, who really work on a water and side product removal. And then we polymerize it and make a new kind of polymer called PLGA. And in these EU projects, what you can also always see is you have also partners that go all the way to the end of the line. So we also process and test the polymers we make. So you integrate all of that. You directly talk to the people who might use your products, especially if it's new products. And we assess all of that, both the recyclability and biodegradation, but also techno-economic analysis and do an LCA analysis of that. So that's 2 projects where we work with a lot of partners in different situations to see how can we integrate such a CO2 conversion process. CO2 is produced in very many industrial sites and urban sites in the world. So we try to really go to different point sources of CO2. We've also worked with airborne CO2, so with direct air capture units. To just see how do these people also think, what is important for them if you want to integrate that with that. I think that's the important part of this symbiosis, that you understand what the different partners want and need and how you can collaborate with them effectively. Yep. That's it. That's our team. We're not a very big team, like 20 people. And yeah, happy to take any questions if you have any.
Yeah, thank you, Erik Schuler, for highlighting the technological possibilities of industrial symbiosis. And yeah, we have now reached the discussion phase. And I think my colleague Mara Wagner was monitoring the questions in the chat. So Mara, maybe you can bring up some questions from there.
Yeah, I think one question we have, I want to, yeah, feel free to ask some more questions also during the discussion. There's one question for James, but I thought maybe it's also interesting for you, Mr. Utikal. It was to James, in your opinion, which governing model would be suitable for different political contexts, for example, in countries such as China, which have a high governmental intervention control?
Yeah, thanks a lot. I saw that. We've actually done several projects in China, and each one has had a different governance model. So the reality is we've actually tested out quite a few different models there. Top down is the obvious one that you would probably think about with China, where you've got a place-based structure where they're looking at either an EIP or they're looking at a region, and they're saying, how do we enact industrial symbiosis there? But again, you get this fuzzy thing. And Hannah, it was really good for you to show how your area, you've actually you've touched on each one of those different governance models to show that these are not hard and fast, straight, rigid lines. It's all fuzzy. And the reality is you get different bits. So whereas you may well have a top-down direction of saying this is what we want to achieve, you then get the governance models of how do we want to achieve it that come into play with the on the ground. So, for example, in Jiangsu province in Nanjing, we had a project where they were looking at regional development, but they were using facilitators on the ground who were working with companies to get data, analyze that data, and then feed back up with this is what we can achieve, this is what's missing. And then they would then create conditions and a strategy to address those missing parts of the jigsaw, so to speak. So the reality is a lot of it does start from the governed, from the last option, but they're then using other aspects of it. They're using ICT to look at the data and make sure that the data is available. And again, with ICT, you can use different aspects of that. You can have it that only the facilitators have access to it, or you can actually have it open for companies to go into it and be able to use their data, put their data in and see all of the data. So the reality is that it's a long-winded explanation, I know, but the reality is it will start with top down is where it will always go to begin with China. And then you would move through the other ones in the actual implementation of it. So yeah, so that's what I would say. Strategic and planned is the starting point.
Maybe I could add one or two examples to that. We did with GIZ and a course in global eco-industrial park training course with participants as well from China, but as well from Ethiopia and Ghana and South Africa. And we realized as well that in the area of China, the example one of the participants showed us that TEDA, that was the name of something like our Center for Industry and Sustainability, they had a research center where they analyzed the resource flows, where they invested in capacity building activities at the local level with the industrial park incumbents so far, so that those opportunities were identified. And in terms of finding new production facilities and industries, they always look for the synergies between those different companies. So that was very interesting. And you do see flowcharts where they're saying, oh, as a next step, we would like to have green electricity in this area. And then will have this and that kind of linkage installed. And this kind of top-down, rigidly planned development of the whole area, we couldn't find in Ghana, for instance, or in South Africa. There was more, oh, let's have an eco-industrial park, and then we see a bit what we can add on afterwards. It was not the whole region centrally planned. So as James mentioned before, yes, it's fuzzy and it's multi-level in its interactions between the different aspects, but you can see different examples as well on how they are proceeding on that topic.
Yeah,
And I think, and
sorry.
one, in terms of if you do have something like a greenfield approach, I think it's very easy to identify those synergies and come up with this top-down level. Once you already have historically grown a structure of different companies on site, and you need to have much more this bottom-up approach and come up with incentives and to make people collaborate. So it's part of the policy framework you've got in the country, but as well depending on the development level you do have in this area.
Hannah, it sounds like you and I have been operating in the same places because we also worked in TIDA, we worked in Ghana, and we worked in South Africa. And you're right, TIDA, like you say, was how you were, and then with South Africa, we were looking at facilitation, and it was sort of tagged onto the National Cleaner Production Centre, who were doing receps, they were doing audits, but they wanted to be able to offer the companies that they were doing an audit on a incentive, and they were using industrial symbiosis facilitation as an incentive, saying, look, we'll come in, we'll do an audit to a cleaner production audit, but when we find an issue, we'll bring industrial symbiosis in to try and help you and give you a carrot to the stick of the recep audit. So yeah, it was very different, the mechanism that they were using to get into companies.
Yeah, thank you so much, both of you, for your comprehensive response. I think the feedback also came just from the chat, and very interesting to hear also other international perspectives on that. I think we have, I saw a bit earlier too, now there's one raised hand in the chat. I don't know, Dusica, if it's possible that someone from the audience can speak to us as well. I think it's Stefan Waldorf. Yeah. That works. Then feel free to unmute and ask the question yourself.
He should have speaking permission.
Sorry, I didn't have any questions, so that must have been a coincidence.
Okay, then never mind. I think then the hand is raised just the way it is. But I think maybe, Elena, you have some more questions, right, for our speaker?
Yes. Yeah, I would have a question for Erik Schuler concerning more going into the direction of market and modeling outlook, and the economic potential economic benefits from industrial urban symbiosis. So I was curious, Erik, what do you think? What is the main what is the market and modeling outlook of CO2-based chemicals and materials in the mid, but also in the long term? And with this also, do you perceive how do you perceive the openness among producing companies towards using these resources stemming from CCU processes?
Thanks. Yeah, that's an interesting one. I mean, it didn't look so good until very recently in terms of just direct cost competitiveness. But with the oil price doubling, I mean, these numbers might look a little bit different. I don't think it will stay that high, but it is more expensive to make chemicals from CO2. And that's the big if there is no price for carbon on it. And because especially with electrochemistry, you don't have as much scaling effects as you might have, volumetric scaling, as you might have with traditional chemistry. It is still we're not like ready to go to the market right now. So it remains, there's some uncertainty of what the achievable price will be exactly in the end. But as we speak, we can't directly compete on price. That is also not necessarily the goal, though. So what we try to do, for example, with our polymers, we try to get as close with price, but we also try to really make polymers that, so we don't try to make exactly the same. So we're not making PET, for example, or polypropylene. We make a polymer that has specific properties, so we can actually beat them, so to say, on performance, which means maybe you need half the amount of the polymer for the same application. Let's think of a bottle. If you have better barrier properties, you might only need half the amount of the polymer to make the same bottle, which is, if it's double as expensive. And in chemistry, you always talk, in chemicals, you talk kilogram price. If you need only half, but it's twice as expensive, you end up with the same price. But you get the benefit of having a more sustainable product that might, for example, also be better for the environment later. And then if you look at modeling, I think CO2 is an interesting one. The nova-Institut has a nice figure on that. If you look at how does the landscape with materials look like, now we have a very high percentage of materials is fossil-based. I believe it's 80+%. And it's not that we have less materials in the future. By 2050, we will have almost a doubling of the material market. But if we want to reduce fossil, we need to really, if you look at the NOAA model, for example, and also other modeling efforts, there is a high share of CO2-based materials. Just by the fact that if you wanted to replace it, you only have a few options. You have waste carbon that is already there, so you have to really increase recycling. You have bio-based carbon, but that bio-based carbon comes from somewhere. So that's waste wood, for example. Otherwise, you would need to plant materials, let's say grains, to get the carbon out of that. And there's with the growth of that market and the replacement, there's so much need for that. We had this discussion a few years ago, especially in Germany, with biofuels, for example. There's just not enough land even to do it. Never mind the impact of the fertilization of all of that, which is also not necessarily sustainable. So really to meet that demand, you will need a lot of CO2-based chemicals. And yeah, I think there's a lot of effort to do. It's not easy to get there. And it will eventually also need more policy frameworks that support this. There's no chemistry framework in the EU at this moment. That's something that is coming up, especially for CO2-based chemicals. There is a lot on sustainable aviation fuels and so on, but no on sustainable chemicals. So there's a lot to do, but the CO2-based chemicals, if you really want to replace all the fossil, will have to play quite a bit of a role there. And we have basically none at the moment. I mean, point something %, but it's basically not existent. Yeah.
Okay, yeah, thank you for elaborating a bit on that outlook. I would ask one last question to everyone to round the discussion up, which is, yeah, where do you see support or funding mechanisms that are still needed? If you would, if you would select something that would really push industrial urban symbiosis initiatives, what would you say is still needed? Also a question for James.
I'll go first. Yeah, I'll go first. One of the things I would like to see is where quite often you have a project, it gets funded, it gets to a certain TRL, and then it therefore doesn't then qualify for further funding to get it over the line so to speak. And the world is littered with projects that were really good ideas, got halfway to commercialization, and then stopped because they couldn't get that extra bit of funding. And I would really like to see a paradigm shift in funding, state funding, effectively, grants, that actually allow you to get to the higher levels of TRLs. But to get, when you move from the lower level to the mid-level to the high level, you actually have to have your collaboration contracts in place so that the consortiums don't fall apart. Everybody knows exactly who owns the IPR and who the exploitation will be. But if you can get all of that sorted, then it opens up access to that further grant funding that gets you to the commercialization stage. And I understand, I know that I understand fully the thinking behind why you don't get that quite often, because people say, well, hang about, we're funding you to get to build your business. But the reality is that there's a lot of really good things that only got so far and then stopped. And then something very similar comes along and does the same thing, gets so far and stops. And then a third thing comes along, gets so far and stops. And it would be much better if we could actually get things to the finish line, to the point that you can actually see them at commercial scale. That would be, I think, a fundamental difference and change in how we actually operate.
I would like to add one or two sentences to that. I think we do have a lot of technology push funding in the sense of, oh, you start up and come with new ideas. And then I fully agree that we do have this value of death. I think in addition to this technology push funding, it might be much more of this market pull funding in the sense that you're creating green markets, like with the ESAF, where you've got quota of green kerosene that has to be used there, and thereby the business case is created. And I would guess the more the business is interested in developing those technologies, the faster the scale up could happen.
Yeah.
I agree.
I would also say those two things very much agree with that, working in a business that has to look for funding all the time. Because also I think, especially if you look at the more chemistry business, the timelines are relatively long and these projects are, well, they're 4 years, but realistically you need 15 to 20 years, if not 25, to have a completely new process in place, and they only get more expensive every step you go. And I think on top of that, what would help is a more long-term strategy, also from a policy perspective, that there is indeed also more certainty for potential investors that want to long-term invest in these things that they know, and we have long-term investors such as pension funds and so on. But they need some certainty, and if there's no policy framework that they know that there will be a market for this thing, and the main figure you get is let's say only from the nova-Institut that, oh, in 2050 we'll have 25%, but there's no policy framework to clearly back that, then I guess the investment decision also for other funding is more difficult. So it would really help if there was more certainty in a more long-term strategy how to implement all of that on a large scale. And then I think also the smaller scale regional incentives will become much clearer. And yeah.
Okay. Yeah, then thank you for this last round of discussion. While you were answering, I already shared my screen with some last questions for our audience. We're, of course, very curious to know what you take out of this webinar. And we will leave these Mentimeter questions open for a bit longer so you can give us your answers. And with that, I thank everyone for their active participation and their insightful questions. And of course, especially, I want to thank all of our speakers, Mara Wagner, James Woodcock, Hannes Utikal, and Erik Schuler for their contributions. The webinar slides will be made available for the participants, and yeah, I wish everyone a pleasant afternoon.